Let's look at the first question we have here. The question says, for which values of X is the identity undefined? Okay, so whenever you have a question asking you about an identity or something being undefined, we have to look at all the denominators within the identity. So looking at the one we have here, let us look at this denominator. Okay, remember, for something to be undefined, what does it mean? What does the denominator have to become if something is undefined?
Ma'am, the denominator has to be 0.
Right. Okay. So that's what we're going to do with these ones, right? You take the denominator. So the first denominator, 1 plus sine x is equal to 0. Okay. That's the first thing that you have to do. Make the first denominator equal to 0, as well as the second one. So you have to do both sides of the equation. Okay. Right, so that's our first step. So once you make it equal to 0, you have to now solve it. And remember, with the general solutions, both sine and cos will have 2 general solutions. So let us solve these 2. So we're going to work on this first one and solve that first. Okay, so inverse operations or balancing method, we're going to take the plus 1 over, it becomes -1. Okay. Then the next step is inverse sine both sides. So inverse sine both sides. Okay, so this side you're left with x equals inverse sine -1. What do we get? On your calculators, remember, put your calculators, reset it, and make sure that the letter that's showing on your calculator is D. If it's an R or G, you're going to get incorrect answers. So inverse sine -1, we get -90 degrees. This is the first general solution, 360 degrees K, and K is an integer. Okay, then the second one, so first general solution, then the second one, 180 degrees minus your -90 plus 360 degrees K. K is an integer. Okay. So the first one, you don't have to simplify it further, but the second one, you're going to simplify further so that it becomes 270 degrees plus 360 K. K is an integer. Okay, so the 2 general solutions for the first one is that one and this one. Okay, so now we have to deal with the cos x is equal to 0 and get the general solution for that one. Okay, so inverse cos both sides. X is equal to inverse cos 0 plus 360K plus and minus. Okay, those are the 2. Okay, so some people like to split it up, right? So when you split it up, you end up with, okay, the first one is 90 degrees plus 63K. K is an integer. And the second one is -90 degrees plus 360K, K being an integer. Okay, so you don't have to split it up. You can literally leave it as plus minus 90, like that. Hi, Mo. K being an integer. Okay, so your 2 general solutions, remember, this is the first one, this is the second one, or you can just express it as plus minus 90 degrees plus 360K, K being an integer. Okay, so that's the first question done, Right, let's go on to the second one. Again, when you're looking for something, same question, for which values of x is the identity undefined? We always look at the denominators. So for this second question, the denominators on the right-hand side, this is just divided by 1, divided by 1. So those ones don't really matter. What matters is this first one here, okay? So for this first one, that's when you're going to say cos x minus sine x is equal to 0. Okay, that's your first step. And again, you want to solve this. So inverse operations or balancing method, cos x is equal to sine x. Okay. Remember, with these ones, there are two ways of working it out. I'm going to do it the easier or the simpler way, right? The simpler way, remember one of our fundamental identities, tan x is equal to sine x over cos x. So I'm going to divide both sides by cos x here, cos x there. So what you end up having is tan x is equal to 1. So this is what we're going to solve here. Okay, so tan x is equal to 1, inverse tan both sides. X equals inverse tan 1 plus the period for tan graph is 180 degrees K. K is an integer. Okay, so for tan, you have one general solution. Okay, so what is inverse tan 1? This is 45 degrees. So 45 degrees plus 180. K is an integer. Okay, so that is your answer for this question. Okay, these are the values of x for which the identity is undefined. Okay, any questions related to these two questions that we've just done? Okay, so just to wrap up, whenever they ask you to, for which values of x is the identity undefined, you look at the denominator on both sides of the equation, on the left-hand side and the right-hand side, make them equal to 0 and get the general solution. All right. Okay, solve the following equations. Right. So you're going to be given a question that looks like this. So cos 3 alpha is equal to sine alpha. And they want us to solve it in the interval where alpha is between 90 degrees and negative 90 degrees. Okay. So with these questions, again, the first step is to always get the general solution. Then after you get the general solution, that's when we plug in our integer values. Okay. So whenever you see a question like this, we now have to use what we call co-ratios. Okay, so co-ratios, by co-ratio, what I'm referring to is, let me use a different color. So what I'm referring to is, we know that sine x is equal to cos 90 degrees minus x. If you're given the cos, then sine, it would be equal to sine 90 degrees minus x. These are what you call your co-ratios or your complementary ratios, right? So we're going to apply this to this question, okay? So what I'm going to do, I'm going to change the sign, okay, so that it becomes cos. Okay, just change the sign so that it becomes cos. Okay, to do that, you keep the cos 3 alpha. Now, on the other side, remember if it's sine alpha, what does it become? It becomes cos 90 degrees minus your alpha. Okay, so now that you have the same trig ratios on either side, what you're going to do next is inverse cos to both sides. Okay, what you do to the left-hand side, you have to do exactly the same thing to the right-hand side. Remember, as soon as you do your inverse cos to both sides, right, what you're going to get is 3 alpha. Remember, you get how many general solutions for trig? You get 2. So one is positive, the other is negative. 90 degrees minus alpha plus your 360 degrees k, k being an integer. Okay, so that's the first step. What did we do? Inverse cos both sides. As soon as you do that, you get your plus and your minus for cos. Okay, so the first general solution is 90 degrees minus alpha plus your 360 degrees k, k being an integer. The second one is negative 90 degrees minus alpha plus your 360 degrees k. Okay, so
Do we need to write it as 1 and 2, or can we just write plus minus?
you can write plus minus. Now, the reason why I'm doing it this way, right, is so that you see we're going to group the like terms. Okay, so these are like terms. Okay, so you're going to have to do it for each of them. So you're going to do it for equation 1, then you're going to do it for equation 2. So for equation 1, right, I'm going to bring the negative alpha over to the other side, and then it's going to become positive, right? So this now is 4 alpha is equal to 90 degrees plus your 360k. Okay. Right. Can you see what I did there? I brought the negative alpha over. It became positive. So 3 alpha plus alpha is 4 alpha. Next step, remember you want to solve for alpha. You're going to divide everything, including the 360, by your 4. Okay. So alpha is equal to 90 divided by 4 is 22.5 degrees, and your 360 divided by 4 is 90 degrees. K is an integer. Okay, so this is the first general solution. All right, now we're going to go on to the second one now. Okay, so the second one, same process. Now for this one, what's important is you have to distribute that negative sign into each one of these terms. So 3 alpha is negative 90 degrees plus alpha plus your 360 degrees k. K is an integer. Okay. This time, if I bring the plus alpha over, it was positive. It's now going to become negative. So 3 alpha minus alpha, I'm left with 2 alpha is equal to negative 90 degrees plus 360 degrees k. K being an integer. Divide everything, okay, by 2. This becomes alpha equals negative 45 plus 180k. K is an integer. Okay, so your second general solution is that one. Okay, now, but we're not done. What did the original question say? They said they wanted us to find the actual values of alpha between negative 90 and positive 90. So if we're using these two equations, right? So we're going to use this one, and we're going to use that one. First things first, you're going to sub in values of k. The easiest one to use is sub k equals 0 into both equations 1 and 2. All right, so the first answer in equation 1, remember, if you weren't here last time, this is how we do it. 22.5 degrees plus 90 degrees times k, which is 0 here. So this just becomes 22.5 degrees. So that's the first one. Into the first equation. If I do the same thing in the second equation, what do you guys think my answer is going to be? You're multiplying by 0, so it's negative 45 degrees. Now, these two values, are they within the range of negative 90 to 90? Do they fall within this range? Yes. 22.5 is less than 90, and negative 45 is greater than the negative 90. So both of these are valid. Okay. So these are the first two answers that we're going to get. Now, I'm going to use or sub k equals 1 into equation 1 and equation 2. Okay. What do you guys think is going to happen here? So if I do that, alpha equals 22.5 plus 90 multiplied by 1. What do you think is going to happen with this answer? So 90 plus, yeah, carry on. Someone wanted to say something?
Ma'am,
Yeah.
so the 90 would say 90 times 1 would be 90,
Mhm.
plus the 22.5, that would be bigger than 90, so it would be too big.
Right. So it's not within the range, so we're going to discard that one. Let's do it for the second equation, right? So alpha equals negative 45 degrees plus 180 multiplied by 1. Okay, so what's going to happen here? So now you have negative 45 plus 180, which gives us positive 135. That's also not valid. So let us now try k is equal to negative 1 into your equation 1 and 2. Right, in equation 1, alpha equals 22,5 plus 90 degrees minus 1. Let's see what happens. 22,5 minus 90 gives us negative 67,5. Is negative 67,5 degrees in our range? Yes, it is. Okay, so it is bigger than the negative 90, so we're going to take this answer. Right, if I sub it into the second one, 22, sorry, it's, what is it? Negative 45. Negative 45 plus 180 minus 1. What do you guys think is going to happen with this one? Is it in our range?
No, ma'am.
Right, so it's negative 225 degrees. It is not in our range, so we don't take that. So our values of theta, okay, are negative 67,5, then the 22,5, and the negative 45. Okay. Right, done. Okay, now on to another similar type question. Again, we want to solve the following equation. So using co-ratios again, okay? So let's go ahead and try the following. So sine theta plus 20 degrees is equal to cos theta. All right. Remember, we said we're going to use co-ratios, okay? Or complementary ratios, right? So if you have sine theta, you could change that to cos 90 degrees minus theta. If you had cos theta, you could change that to sine 90 degrees minus theta. Okay, so the idea is I want to get either all causes, okay, or all sine. Right, so I'm going to change this one. You don't need to show this, by the way. This is just something I was illustrating for you. What I'm going to do, I'm going to change this cos here. Okay, so it's going to become sine theta plus 20 degrees is equal to cos theta becomes sine 90 degrees minus theta. Okay, now that everything is in terms of sine, you can do inverse sine both sides, right? Then you're left with theta plus 20 degrees is equal to 90 degrees minus theta, okay? Plus your 360 degrees k. K is an integer. Remember, this is the first equation. Second equation is theta plus 20 degrees, 180 minus your 90 degrees minus theta, plus your 360 degrees k, and again, k is an integer. Okay, so always remember, if it's sine or cos, you're always going to have two general solutions. I'm going to simplify this by grouping all my thetas on the one side and then the angles on the other side, right? So let's take equation 1. Let's see what's going to happen with equation 1. It was negative. If I bring that theta over, negative theta, it's going to become theta plus theta, which gives us 2 theta. You had plus 20 here. If you take it over to the other side, it becomes 90 degrees minus 20 plus your 360 degrees k. K is an integer. Okay, we're not yet done, right? What are we going to do with, yes, Mo? Go for it, love.
Ma'am, I wanted
Mhm.
to ask where did, for the second, I see for the second equation, where did ma'am get 180 minus and then the reference angle?
Okay, so remember for sine, okay, I'm just going to move to the side quickly, right? For sine, if you have sine theta is equal to m, right? This is a random value. You're going to get two general solutions. The first one, inverse sine both sides. Okay, inverse sine m plus 360 degrees k. K is an integer. The second one, okay, this is when you say 180 minus whatever this is here. So that's why we say 180 minus your inverse sine m plus 360 degrees k, like that, okay? So you get one that's just inverse sine m, and then the other one is 180 minus inverse sine m. Where do we get this from? If you look at your cos diagram, at what points can sine be positive? It's in the first quadrant where all of them are positive, and the second quadrant where sine is positive. What's the angle here? It's the ones here, 180 minus theta. So this is where the 180 minus theta comes from. Okay.
Thank you, ma'am.
All right. Going back to this one. Okay, at this point now, you're going to divide everything by 2. So theta equals 70 divided by 2, that's 35 degrees, plus 180 degrees k. K is an integer. Okay, let's look at this. So this is the first general solution, right? Second one. Okay, you're going to have to distribute that negative into the bracket. So what am I talking about? I'm talking about this negative sign into there. And then you're going to group your like terms. So let's take the second equation, which is that one. So theta plus 20, this is 180 degrees minus 90 plus theta, okay? Plus your 360 degrees k. K is an integer. So theta 180 minus 90 is just 90 plus theta. So what do you think is going to happen here with the thetas? Okay, it was positive. If I bring it over, it's going to become theta minus theta. Okay, so here the answer you get is just no solution for this one. Okay. So the answer for this one is no solution. Okay. Ooh, so
Good, ma'am. Please scroll up.
oh,
Just
scroll
small
back
little, please.
some more. Is that okay? Okay.
Thank you,
Okay.
ma'am. I
All
got it.
right. All right, sure. Now, what we're going to do now is in your book, it's called ratios in terms of a letter. Okay. All right. So the questions will be like this. If tan 28 degrees is equal to P, write the following in terms of P. Okay, so what this means, right? They've given you a triangle basically, right? So they've given you 28 degrees here. Okay, it's a right angle triangle, right? This is your hypotenuse. This is your adjacent side, and this is your opposite side. Okay, so when they give you this, tan 28 degrees is equal to P. The P can be written as a fraction by doing it what? By writing it as P over 1. Remember, tan theta is equal to the opposite side over the adjacent side. So what's the opposite side here? The length of the opposite side is actually equal to P. And the adjacent side, okay, is equal to 1. What we need to do now is work out what the hypotenuse is equal to and what this angle is equal to. So what do we do when we have questions that look like this? You start by step 1, solve the triangle like I'm doing here. Solving the triangle, I want to work out the hypotenuse. We're going to use Pythag. So hyp squared is equal to the opposite side, which is your P squared, plus your adjacent side, which is 1 squared. And you always need the reason, which is Pythagoras. Okay, so P squared plus 1. Whenever you have a squared there, we're going to take the square root of both sides. So the hypotenuse is actually equal to the square root of P squared plus 1. Okay, so that's the length of the hypotenuse. Let's figure out what this missing angle is here. Okay, this one that should be in this position here. So the missing angle is just 180 minus your 90 minus the 28. Okay, you'll see how we're going to use it later. So 180 minus 90 minus 28 gives us 62. Okay, so this angle up here is now 62. Okay, so we've solved the triangle. We found all the missing sides. We found that the hypotenuse is actually the square root of P squared plus 1. We needed to show Pythagoras. Okay, if you don't show Pythagoras there, the reason you're not going to get your 4 marks. Okay, right. So first thing, we've solved the triangle. Now they want you to write, sorry, was this 10? Oh, I used 10, that's fine. Let us write sine 28 degrees in terms of the letter P. So sine 28, we know that sine theta is equal to the opposite side over the hypotenuse. What was the length of the opposite side? Opposite side was equal to P. The hypotenuse was what we just found, which is your square root of P squared plus 1. Okay, so just by doing that, P over square root P squared plus 1, you have written the ratio sine 28 degrees in terms of P. Okay, perfect. So we've done sine 28. Let's do cos 62 degrees. Okay, now 2 ways of doing this. Either you could have done it like, remember we found the 62 here. So cos 62 is actually, I'm just going to write here, cos 62, this is the adjacent side over the hypotenuse. The adjacent side, the side that's adjacent 62 is what? Is P, right? So this one is going to be P over the hypotenuse, which is the square root of P squared plus 1. Okay. Or you could have said, let's use co-ratios. So cos 68 is actually equal to sine 90 degrees minus your 62, which is just equal to sine 28. So it's the same ratio, P over P squared plus 1. Okay, that's A, B, C. What is cos 208? Now, if you're given anything that's not an acute angle, like here, we have 208, right? So if it's 208, which quadrant is it in? That's not in the first, it's not in the second. That means it's in the third quadrant. Anything in the third quadrant is 180 degrees plus something. Okay, so here we have to reduce it. So cos 180 plus some value. What's that value that's going to give us 208? It is 28. Okay, that's what gives us 228. So let's reduce this. Only tan is positive in the third quadrant. That means when I reduce this, it becomes negative cos 28. So this reduction earns you 1 mark. Then after that, you then need to work out cos 28 in terms of the letter P. You keep the negative sign here, okay? So I don't have to scroll back up. Remember, you had your 28 here. This was P, this was 1, and this is P squared plus 1. So cos 28 adjacent over hypotenuse is, so adjacent over hypotenuse, this is equal to negative 1 over the square root of P squared plus 1. Okay. And let's say they gave you a negative angle. So tan negative 332. What happens whenever you're given a negative angle? Okay, so whenever you're given a negative angle, always add 360. Okay, so let's add 360 here. So 360 minus 332, this is tan 28. So for this reduction, you get a mark. So tan 28, which is what we had at the beginning, is equal to P.